Good evening, my name is Katie, and today we are going to be going over Module 2, Chapter 2 for Math for Teachers 1 for the fall of 2019 course. So jumping right in here, we have what is called a set. So we're going to be looking at the operation of the set and finding some of the like similarities of this set. So looking here, let's go ahead and get our blue out. We have a Venn diagram, and we made these different colors so that we could help kind of differentiate whenever we go to put the variables into the set. So we know that a set can be made up of many things, really anything in the universe. So it can be made up of people, vehicles, numbers, letters, anything under the sun, colors. But in this set, we have that the set is made, the universe is made of A, B, C, D, E, F, G, and H. We know that A has B, C, D, G, and H, and the set B is made up of D, F, H, and then the set C is made up of D, G, and H. So whenever we were setting this up, we of course put here that this is of course what's in the entire universe. And then we go through and we label. First we have A, B, and C. So we know that those are how we're going to divide it all up. And from there, all we do is we look and we see, okay, so I know that B is going to be in the Venn diagram, the circle of A. But is B in any other set? No. So it goes right here. And then as well as C. So C is not. But then we get to D. And so we say, D's here, and here. So all three sets A, B, and C have that in common. So of course we're going to put it in the middle. All right, and so we keep doing this and we go through each one of them and we find, let's go ahead and erase these marks so we don't confuse ourselves in a little while. Come on, let's go. Okay. So we end up seeing later on, that this is what it in the end will look like. So let's go through and let's find, we have some questions here, and find what it's asking. So the first one is B and C. So it wants to know what is inside both B and C. So we see that we have D is both inside B and C. And we see that F and G. So I put these in alphabetical order. You don't have to, but I did just to keep it straight in my mind. So we have D, G, F, and H are in both B circles and C. Now you may ask, well, Miss Katie, why didn't we put B and C? Well, because they're in A. And all three circles, A, B, and C, share D. And then we see here that A and C share G. And this is an empty set here and an empty set here. So let's continue. And I see that we should have this here. So A and B. So what this is asking is, what do they have in common? So A and B have D and H in common, okay? So then we take a look at B and C. Well, what do B and C have in common? Again, D and H. Well, what about A and C? So we know that that is anything that is inside both circles. So A and C have D, H, and G. So then we go to E here. And we have, with this, it's saying anything that is not inside. So anything that's not inside of A. So we see the only things, because all of these here, if it's in this orange circle, than it is inside. So that right there should not be there. That was a typo on my part. But F. F is the only thing that is not inside A. And then we go on to A and C. So we have here D, G, and H. And we see that here, D, G, and H. And then for this last one here, it's wanting to know what is A, B, and C. So we are looking at, and let's just change to a different color. It's wanting to know what is inside of here, 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 and here. And that is how we'd work the first one. So moving along, we have something very similar, and that is, so in the universe, like we said, we can have anything. So now we've changed to colors and shapes. So we have a little key here because it would take quite a lot to write out each of these things. So we have a key. So let T be triangle, C be circle, H be hexagon, R be red, B be blue, L be large, and S be small. So you see here how we label it. So this one is a hexagon, it's large, and it's red. Okay, so maybe take a look at this one. It's a triangle, it's small, and it's blue. We didn't have to label those things, but for me, it just makes a little bit more sense to go ahead and label them. It kind of helps me keep my mind straight. So keeping in mind what we learned from the last one, this is wanting to know what does L and H have in common. So here's an L and here's an H. Well, and so we know that if I look at every single one of those, the ones that have L and H are the large hexagons. Okay, so then we move on to C and H. So we know here that the C's are circles and the H's are hexagons. So we would label that circles or hexagons. So this is wanting to know what is T. So we know that this right here means anything but T. Okay, so anything but T. T is triangles. So an R. So we know that it's red shapes that are not triangles because of that symbol right there. And then what are these? So it's C, S, and R. So we know that that is a small, red, or circles. Anything that's going to be small, red, and circles. Okay, so moving to the next one. Okay, so these are kind of fun. So these, we are going to take these symbols and we are going to assign a value to them. So these are actually, you know how we have Roman numerals? Roman numerals are here. These are actually Egyptian numbers. So what we're going to do is we're going to look at the symbol and we're going to use the key to assign a value to each symbol. So writing this out, I see that we have 1, 2, 3 symbols that equal 10,000. So let's stop and think. I could write 10,000 plus 10,000 plus 10,000. But isn't that the same thing as saying 10,000 times 3? I think so. So let's write it like that and see if that might save us a little bit of time, okay? So 10,000, 1, 2, 3, 4 circles or O's and place our comma times, I'm sorry, I'm writing a 4. Let's see here. Times 3. So what is 10,000 times 3? It is 3, 0, 0, 0, 30,000. Okay, so then we're going to move on to the next one. So what does this symbol here equal? What is the value of this symbol right here? So looking at our key, it's this one. So it equals 10. So using the same thing that we did for the last one, let's put 10 times, do y'all hear that rain? 10 times 1, 2, 3, 4, 5. So 10 times 5 equals, that looks like a Z, but it's an equal sign, 50. Okay, and then moving right along, so what about these right here? What a coincidence that they look like ones and they equal the value of 1. So let's put a 1 there and count. We have 1, 2, 3, 4. So 1 times 4. And we know that anything times 1 is itself. So 4. So same thing as saying 30,000 plus 50 plus 4, let's place our comma, equals 30,000. Ooh, good knot. Let's try that again. We're going to have to get a stylus, y'all. Is 30,054, right? Right. Okay, so moving along, this one, now that we know that we can take a symbol and assign a value to it, we are going to do the same thing. So I typed these out to save us a little bit of time because we know now. So let's check and make sure, because I might have put something in here to trick us up. So starting with M, the Roman numeral M equals what? So I find M and I see that it equals 1,000. And how many are there? 1, 2. So 1,000 times 2 is 2,000. All right, so what about C? C is 100, so 100 times 1 is 100. Moving along to X. X equals 10, so 10 times 1, 2, 3. 10 times 3 is 30. And then, let's see. You know what I missed is V. V equals, that's fine though, we can just place it down here. V equals 5. 5 times 1 equals 5. So let's just put a plus here. 5 equals. There we go. No problem. And then we see the last one here as a 1 and 1. So 1 times 2 is 2. So taking this here, we see 2,000. So all we do is we take the values and we find, we take the symbols, find their values, multiply them times however many there are, and then we take whatever that sum is, we add them together, or the product is, add them together to find the sum, and that equals the sum of all of the values. So let's see, 2,137. So 2,137 would be our answer there. So moving along here, again, all we're going to do is take the symbols and we are going to find their values. So we see here using our key that we have 10 times 1, 2, 3, 4. 10 times 4 is 40. So I can say 40. And then 1. So 1 times 1 is 1. 40 plus 1 equals 41. So we're getting the gist of that. Okay, we can add them. But what about this? What about a little bit more tricky one? So we can take this one here. And again, all we're going to do is find the value for each symbol, okay? So this one is different because it is actually with a base of 20. So I have here again a key that I used to help me find these numbers here. So all I did was do 5 times 7,200, and that gave me 36,000, plus 6 times 360 is 2,160. 3 times 20 is 60. And 17 times 1, again, anything times 1 is itself, so 17. And then all we're going to do, I know that looks kind of scary, but all we're going to do is just maybe line them up here like this. It always helps me to see it up and down versus side to side. It helps me kind of keep those numbers in columns to help me add them together. So I have 7, 6 and 6 is 12, plus 1 is 13. Of course, we're going to carry our 1. So 1 plus 1 is 2. 6, 7, 8. And then there's nothing there to add it to, so we just bring it on down. And we see that this has a value of 3, 8, 2, 3, 7. So 38,237. So I know that the way that we just saw it is a little confusing sometimes. So here's a helpful tool to help us multiply. This is called lattice multiplication, and it's really fun. All you do is you take a look and you see that you have a 2-digit number times a 2-digit number. So that tells us how we're going to set up our box. So we have 2 boxes here and 2 boxes here. So we're going to place a 2 and an 8 for 28 times 32. Okay, so all we're going to do is we're going to just say 2 times 3. 2 times 3 is 6, right? So we're going to place a 6 there. And you may be thinking, well, there's 2 boxes, you know, or this box is cut in half. So to help me, what I do is I just place a 0. That way, we know 0 equals nothing. So we just have it there as kind of a placeholder, rather. So then we do 8 times 3. So let's see. Is 24, 2, 4. And then we do 2 times 2. 2 times 2 is 4. And then we say 8 times 2 is 16. 1 and 6. It is sure raining hard, isn't it? Okay, so from here, all we're going to do is we're going to take each of these. So we're going to say this. So 6, we have nothing to add it to, so it's just 6. And then we're going to add this together, this diagonal. So 4 plus 4 is 8, plus 1 is 9. And then we move on to this one here. So 6, 7, 8. And then this is just 0. So we don't even have to bring that down, but let's go ahead. So it's safe to say that 28 times 32 is 896. And then we can just type it into our calculator just to double check ourselves. Because isn't it great we have all these resources to double check ourselves? And it is right here. 896. 28 times 32 is 896. So this one here, I already did place the values so that we could save some time. So again, on this one here, we knew that we had 2 digits, so we placed 1, 2 boxes. Well, now we have 3 digits in each number, so we have 1, 2, 3 by 1, 2, 3. Okay? So we're just going to take and we're going to add this one, this one, this one, this one, ooh, missed it there, this one, and this one. Now something very important that I did not remember to tell you is that you always have to start on the very right hand side. It's kind of different because we read from left to right, so just think that this is kind of backwards. So we're going to actually start from the right to the left, okay? So we're going to start here and say 4, and then 6 plus 6 is 12, plus 2 is 14. Okay, so we have 14, but we can only put 1 here. So what do we do with it? We carry it, okay? So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we keep the 4, carry the 2, 4, 5, 6, 7, 8, 9, 10, 11. 1, carry the 1, 4, 5, 6, 7, and 1. So then we just write 100, 7, 1, 4, 4, and 4, add our comma, and then let's check ourselves. 273 times 628, in fact, equals 171,444. So that's just a great tool to help us check ourselves. So these are worked out, and we can see here exactly what we did in the last 2 problems. We had 3 digits, right? So we set up our boxes appropriately. 1, 2, 3 by 1, 2, 3. And then from there, we just placed our numbers on each of them, multiplied each. So 9 times 5 is 45, 6 times 5 is 30, 4 times 5 is 20, so on and so forth. And that's the same thing that you do on all of them. You just go down the row on each of them. And then what we do is we start from what? The right to left, and we add. So 2 plus nothing is 2. 8 times 1, 8 plus 1 plus 6 is 15. So I place the 5, carry the 1, and so on and so forth. Again, and then we just read from left to right then, and we place the number. So 571,652 would be our answer there. Now moving on, we have a 4-digit number. That's okay. Don't freak out. All we have to do is add another box. So we have 1, 2, 3, 4, and then our second number there is 3 digits. So 1, 2, 3. If this had 10 digits, that second number, all we would do is just place 10 boxes down the row and of course carry it out to the side. So that would take a long time to do. Thankfully we have calculators for that, but that's the way that lattice multiplication works. So moving along, we are going to round to the leftmost digit and then we're going to estimate. So we know that this sign here is our equal sign, correct? So with that, whenever we round to an estimate, we actually change up that equal sign a little bit. We still know that it equals, but it's an estimate, so it's not exact. So we actually make it this squiggly, 2 little squiggly lines instead of the straight across equal sign. Okay, so what we're going to do, we know that whenever we round, if it's 5 or over, we go up, and if it's 4 and below, anything under 4, we're going to round down. Okay, so taking a look at these, we are going to say 888 rounds to what? So it's an 8, which means it's over a 5, right? So we are going to round up. So we round to 900 plus 465. So 465, that 6 is what? Over the 5, and of course there's a 5. So we're going to round up to 500. Now taking a look at the bottom number, it's 134. So with that, because the 4 is of course below the 5 and the 3 is below 5, what we're going to do is actually round down. And so that equals 900 plus 500 all over divided by 100. So then we just, of course, add those top two numbers, which gives us 1,400 over 100. We divide that, and it equals about 14. So we do that for the next couple of problems, of course, keeping in mind that rounding up and down. We see here that it's not always going to be an exact, perfectly round number. Sometimes it's going to be a decimal. And we can do large numbers, small numbers, but that is how we round to the leftmost digit and then give an estimate. So here's something that we saw earlier. We used a base of 20. So with that, we were multiplying and then adding. What we're going to do now is we're actually going to add with a base of 5. So we use in our day-to-day life, we use a base of 10, and that's standard. And this is just changing it up so that we will understand, of course, how addition works and how it can change for different scenarios. So what we're going to do here is just add. So we have 3 plus 2, or 2 plus 3, and that equals, let's see here. I'm forgetting how to do this, so I'm going to have to jog my memory. So we have, now with this we can't have 5. So we have 5, but we can't have 5, so we're going to have 4 and carry the 1. So then we have 3 plus 3 is 6 plus 7. So if we say 7 minus 5, it equals 2, and we're going to carry the 1. And then 4 plus 1 plus 1, so 4, 5, 6. Of course, we can't have that, so 6 minus 5 is 1. We carry the 1, so 1,124. Now, with this, we were earlier taking and we were putting into our calculator to check. We can't do that here because, of course, our calculators run on a base of 10, and this is a base of 5 and 6. So here I have 6, and I have, we of course change our base to 6, and I have it worked out for us. So all we did there, same thing we did here. We can't have 6 as a number here at the bottom, so we would have to, of course, subtract it, carry the 1, and so on and so forth. So we have a good concept of addition. Now what about subtraction? Okay, so what we're going to do here is we, of course, know borrowing. We know how to do it with the base of 10. Let's do it with the base of 5, okay? So we have 4 minus 3 is 1. Something I forgot to mention on this one here is that it's not just 1,124, it's 1,124 with a base of 5. You have to write the base there so that we know, because we would of course assume that it is the base of 10. So just remember to write that always with it. So let's go ahead and write 5 here, so that way we don't forget on this next time. Okay, so 4 minus 3 is 1. 1 is not higher than 5 or at 5, so we're good with that number. 1 minus 4, we can't say 1 minus 4 because that would give us a negative number, but we can walk to our neighbor next door and we can borrow. Now, we're not borrowing 10, we're borrowing 5. So what is 5 plus 1? 6. So I say 6 minus 4 is 2. and then there's nothing there to subtract from 3, so it's 3. So our answer is 321 with a base of 5. Here again, I have this equation worked out for us. We have 503 with a base of 5, subtract 24 with a base of 5. We, of course, carry our numbers, borrow from our neighbors. And that is all I have for us this evening. I hope we all had a very educational evening, and I look forward to seeing you the next time.